Hi all, welcome to new class. Today's class is the continuation of economics of power generation, that is the problems related to cost per unit generated. So let us continue the problems. A generating station has the following data: installed capacity equal to 300 megawatt, capacity factor is 50%, annual load factor 60%, annual cost of fuel, oil, etc. rupees 9 into 10 raised to 7, then capital cost rupees 10 raised to 9, annual interest and depreciation equal to 10%. Calculate the minimum reserve capacity of the station and the cost per kWh generated. So the first question is to find the minimum reserve capacity. It is the difference between the planned capacity and the maximum demand. So here planned capacity is the installed capacity and the maximum demand is not given here. Instead we have capacity factor and annual load factor. So capacity factor, we have capacity factor equal to average demand divided by installed capacity or planned capacity. And also the load factor. Load factor is equal to, it is average demand divided by maximum demand. So here we can divide this capacity factor and load factor, that is divide capacity factor with the load factor, then we will get maximum demand divided by the installed capacity. And that is equal to, what is capacity factor? So capacity factor is 50%, that is 0.5, divided by load factor is 60%, that is 0.6. Then what is maximum demand? So maximum demand is equal to 0.5 divided by 0.6 into the installed capacity, that is 300, and that is equal to 250 megawatt. So this is the maximum demand. Now we can find the reserve capacity, that is reserve capacity is equal to, it is the difference between the planned capacity and maximum demand, that is, or installed capacity minus maximum demand, that is 300 minus 250, and that is equal to 50 megawatt. So this is the reserve capacity. Now we have to find the cost per unit generated. So to find the cost per unit generated, we have to find the fixed charges and running charges. And here it is given that annual cost of fuel, oil, etc. is rupees 9 into 10 raised to 7. So it consists of the running charges. So this is the running charges. And to find the fixed charges, here we have annual interest and depreciation is 10%. We have to find the fixed charges, then add the running charges, then we will get the total charge, and we have to find the cost per unit generated. And here the units generated is not given, so we have to find the units generated also. So first of all, find the units generated. So units generated per annum is equal to we have maximum demand into load factor into hours in a year. So maximum demand we have got as 50 megawatt. So here we have to consider in kilowatt. So into 10 raised to 3. Then into load factor is 0.6. Then into hours in a year is 8760. And we get it as 1314 into 10 raised to 6 kilowatt hour. So this is the unit generated. Now we have to find the annual fixed charges. So annual fixed charges is equal to, it is given that annual interest and depreciation is 10% of the capital cost. So 0.1 into 10 raised to 9, that is equal to rupees 10 raised to 8. Then we have to find the annual running charges. So annual running charges is equal to annual cost of fuel, oil, etc. consists of the annual running charges, that is rupees 9 into 10 raised to 7. Now we can find the total charges, that is total annual charges is equal to, add these two. So rupees 10 raised to 8 and rupees 9 into 10 raised to 7. And we get 19 into 10 raised to 7. Now we can find the cost per unit generated. So cost per unit generated is equal to, cost is, here this is rupees. So 19 into 10 raised to 7 divided by units generated is equal to this one, that is 1314 into 10 raised to 6, and we get it as 14 paise. So this is the cost per unit generated. Let us do another problem. The annual working cost of a power station is represented by the formula rupees A plus B kW plus C kWh, where the various terms have their usual meaning. Determine the values of A, B and C for a 60 megawatt station operating at annual load factor of 50% from the following data. So the data given are: capital cost of building and equipment is rupees 5 into 10 raised to 6. Annual cost of fuel, oil, taxation and wages of operating staff is rupees 9 lakh. Then the interest and depreciation on building and equipment are 10% per annum. Annual cost of organization and interest on cost of site, etc. is rupees 5 lakh. So here we have to find the values of A, B and C. And A, B, C, these terms consist of, this is the first term consists of the fixed cost. So this is in 3-part form. So first term consists of the fixed cost, then second term consists of the semi-fixed cost, third term consists of the running cost. So what is A? A is the annual fixed cost. So A is the annual fixed cost. So here what is annual fixed cost? The annual fixed cost is due to the annual cost of organization and interest on the cost. That is annual cost of organization and interest on cost of site consists of the annual fixed cost. So what is A? A is equal to 5 lakh. 5 lakh rupees. Now we have to find B and C. So the second term consists of the semi-fixed cost. So first of all we have to find the value of annual semi-fixed cost. So what is semi-fixed cost? This is on account of the annual interest and depreciation. So annual interest and depreciation on the building and equipment consists of the annual semi-fixed cost. So it is given that it is 10% per annum. So it is equal to 10%, that is 0.01 of the capital cost, that is 5 into 10 raised to 6. So we will get 5 lakh. So this is annual semi-fixed cost, and that is equal to B into KW. That is, this is equal to B into KW. KW means it is the maximum demand. B times maximum demand is equal to the annual semi-fixed cost. So what is KW? So B into maximum demand is equal to, it is given that 60 megawatt station. So 60 into 10 raised to 3 is the maximum demand, and that is equal to 5 lakh. So we can find the value of B. B is equal to 5 lakh divided by 60 into 10 raised to 3, and that is equal to rupees 8.34. Now we can find the value of C. So C is the third term, that is, it consists of the running cost. So running cost means C into KWH is equal to the running cost. So we have to find the annual running cost first of all. That is, annual running cost is equal to, and this is due to the fuel, oil, taxation, wages of operating staff, etc. So that is equal to 9 lakh. It is 9 lakh is the annual running cost, and the running cost is equal to C into KWH, that is equal to 9 lakh, and here we have to find the value of KWH, that is the units generated per annum we have to find. It is not given in the question. So first of all we have to find the value of units generated per annum. So units generated per annum is equal to maximum demand into load factor into hours in a year, that is 60 into 10 raised to 3 into 0.5, that is load factor is given as 0.5 into 8760, and that is equal to 262.8 into 10 raised to 6 kilowatt hour. So here we can find the value of C. So C is equal to 9 lakh divided by that value, that is 262.8 into 10 raised to 6, and we get it as rupees 0.0034. So this is the values of A, B and C. So in this way we are finding the values of the constant terms A, B, C in the 3-part form of cost of energy. So that is about the problems related to the cost of electrical energy. Thank you for watching the class. If you like the classes, please like, share and subscribe my channel.